I am Olarewaju by name. I am your physics tutor for today. I'm Top, and we are here to talk about the topic known as equilibrium of forces. Again, the topic is known as equilibrium of forces, as we have seen. But before we move on into the question on the board, we need to understand and familiarize ourselves with what is known as equilibrium. Now, what is equilibrium? You must have heard this word equilibrium in the some subject as economics, but in physics is a bit different to what we have in economics. Now, what is equilibrium? Now, equilibrium is attained, or equilibrium is a condition whereby the net force attained on a body, a net force attained by a body is equal to 0. What do I mean by net force? Net force means the total force acting on that body is equal to 0. What do I mean by total force? Just the way you are seated or you are standing. You are able to stand firm just because of your legs, and the total forces acting on you equals to 0. What do I mean by that? I mean, the force that is pulling the object upwards and the force that is pulling the object downwards, they are all equal to 0 when you add them up. That's what I mean by net force. What I mean is, if you want to understand the concept known as equilibrium, the total force acting on that object must be equal to 0. What I'm going to take for instance, let's take for instance, you are sitting on a chair and you have 8 Newton acting on you, pulling you upward, and you have -8 pulling you downward. By the time you add 8 minus 8, the net force there is what? 0. So one thing you need to take note of is that the total forces acting on that body must be equal to 0 for that object to be in what? Equilibrium. So please take note of that. We all know what force is from this is 1. Force is the entity that causes motion. Force is the entity that causes motion. We have types like contact and non-contact forces. We have contact forces like push and pull, tension, and the likes. And we have non-contact forces like gravitational force and magnetic force, and including electric force. So we are not talking about forces, we are talking about equilibrium. Now, I've told you what equilibrium is. Now, if you look at it again, under this equilibrium, I told you equilibrium is a condition that must be met. So please take note of that. Let's say, for instance, we have an object like this. We have a ruler like this. If this ruler is placed on the ground, nothing moves it because it obeys Newton's first law of motion that says an object will be at the state of rest until an external force acts on it. So now, what I'm trying to say is that let's assume I now place it on a pivot like this. I place it on a pivot. Now we will notice that there will be some certain downward force that will pull it down, and there will be some certain upward force that will pull it up. So it will get, this ruler will maintain equilibrium until when there is no more shaking again. If the ruler is no more shaking about this point where the pivot is located, automatically this ruler is set to be at equilibrium. So we need to take note that the upward forces pulling this ruler upwards and the downward forces pulling this ruler downwards must be equal for this object to maintain equilibrium. So we need to take note. Again, this object placed here is what's called a pivot, as I've said, and this is what? Ruler. So we need to take note of that. And under this equilibrium, we have two main classes or two main types of equilibrium. Again, I believe you understood what equilibrium of forces is. The net force acting on it must be equal to what? 0. So now, under this equilibrium, we have two types. We have stable equilibrium, and we have static equilibrium. Sorry for the mistake. We have static equilibrium, and we have dynamic equilibrium. What do I mean by static equilibrium? Static equilibrium is when the net force acting on an object at rest is equal to 0. What do I mean by object at rest? Object that is not moving, object that is on a spot, object that is not undergoing motion, object that is not moving at all is object at rest. So when the net force acting on the body at rest is equal to 0, then such type of equilibrium is known as what? Static equilibrium. So it shows that the object is not moving at all. But the other type of equilibrium known as dynamic equilibrium is simply a type of equilibrium whereby the object is moving. That means the object preventing the forces preventing the object from moving, and the forces that is causing the object to move, their net force is equal to 0. Now please take note. In dynamic equilibrium, the object must be moving. Again, in dynamic equilibrium, the object must be what? Moving. And what is going on here? If the object is moving, there are two forces working on that object. We have the applied force making the object to move, and we have the frictional force that is opposing the motion of the object over another. So what are we trying to say? What are we trying to say? It means that if we take, for instance, the forces applied and the force and the frictional force, if the addition of the frictional force opposing the motion and the applied force, these are the two forces, if they add the two net forces together and they are equal to zero, automatically that type of equilibrium of that object is known as dynamic equilibrium. Again, a moving body has two forces acting on it, an applied force by the person that is pulling it, and the frictional force that is opposing the motion. So if the net force of the frictional force and the applied force is equal to zero on the moving body, automatically that equilibrium is known as the dynamic equilibrium. Now let's look at this question together. So we'll solve it together, then we'll see our level of understanding. Now, let me clear this off and move on to solving this. Looking at this example on the board, a uniform beam of length 6 meters. Now, we have been told the length of the uniform beam. Now, anytime we hear the word uniform means the beam is completely measured. The beam is free of deformities. That's what it means. Now, the length of the beam from here to this place is what? From 0 meters to what? 6 meters. According to the question of length 6 meters. It's pivoted at 2 meters. Now, we all know that 2 meters is after 0, but it's not up to 6. Now, it is pivoted at where? The 2 meter mark. Now, a force of 15 Newton is pivoted at what? 5 meters. We all know that 5 meters is before 6. Then a force is placed here at what? 5 meters. So, a force we don't know, okay, 15 Newton force, sorry. A force is what? 15 Newton. And it's placed at what? The 5 meter mark, according to the question. Now, calculate the moment of a force about the pivot. Now, if you want to calculate, don't forget that a force has been placed here. Automatically, a force will be placed here. But now, we are not giving a force here. For us to know, now, this is the force that has been placed here. Don't forget that if from here to here is 5 meters, according to length, and from here to here is 2 meters, according to length. Automatically from here, from this point to this point, automatically will be what? 5 minus 2, which gives 3 meters. Again, from here, from 0 meter mark down to the 5 meter mark is 5 meters, according to the question. From here to where the ruler or the beam was pivoted is 2 meters. So automatically from 2 down to 5 will be 5 minus 2. That gives what? 3. Now I want to calculate my movement. Movement about the pivot is what? The force at the 5 meter mark times the distance down to the pivot. Please take note. We are only concerned about the distance of the force to the pivot. We are not concerned about any other force away from the pivot. So the distance to the pivot is what I need, not these 2 meters. So please take note. So it is what? The force 15 Newton times the distance 3 meters. So we have it as what? 15 times 3 will give what? 45. Then Newton times meter will give me Newton meter. So that is the conclusion to such question. So please, if there's any question, you ask me and I will make you understand it better. So that ends the solution to this. So if there's any question, so now let's look at an assignment now. Let's look at some questions. Let me give you some questions so you can attempt it. Now looking at this assignment, which is very, very similar to what we have just attempted. We have the question that says, a force of 20 Newton is applied to a spanner that is 0.5 meters long. What is the moment of the force? Moment of the force. Now, it's an objective question. Let me give you the options. So, when you solve, you can check if you are correct. 10 Newton meter, option B. Option C, 20 Newton meter. And option D, 40 Newton meter. So, please, if there is any question as regards equilibrium of forces, the beginning part, you can please let me know. So, we'll solve more on it. So, equilibrium of forces is something very straightforward and easy. And the reason why I picked this question is because many students are always struggling at this topic, be it in SS3's WAEC or be it in the national exam, they find it tough. And we all know that the exam next year is not the CBT, so you don't have much time to be dissecting things on paper like this. So I want you guys to be able to know it without even writing much. So I wish you guys all the very best. So this is an assignment for you guys to work with. So you can choose you can solve and choose your answer to see which one is correct. Thank you so much. Once again, I'm Top. I'll be a physics tutor. So in the next class, we'll move on into tougher examples on equilibrium of forces. Thank you so much.